Okay, so for this first problem, we are going to be designing a runway. Okay, you're designing an airport for small planes, and one kind of airplane that might use this airfield must reach a speed of takeoff or before takeoff of at least 27.8 meters per second and can accelerate at 2 meters per second squared. Now, the only reason I've put this in here, this 100 kilometers per hour thing, is that the problem originally had 100 kilometers per hour instead of 27.8 meters per second. Remember that we can turn kilometers per hour into meters per second by dividing by 3.6. If we do that, we get 27.8, and we've known that trick for most of the year. Okay, so anyway, if the runway is 150 meters long, can this airplane reach the required speed for takeoff? And so when I go into these problems, I like to tell myself, I don't know how to solve this problem, because it makes me feel good when I actually do solve the problem. I go into this and say, I don't know how to solve this problem, but I know how to start solving this problem, and I know that my strategy will lead me through the problem, and so I want to show you how that happens. So I don't have to know how to solve the problem in order to create a motion diagram. Okay, I know how to do this. I create my frame of reference with an origin at 0 and a positive x-axis, and then I start collecting information. That's the process, right? I collect information. First piece of information I collect is the initial position. And since I haven't been told what the initial position is, I can go ahead and say that the initial position is going to be 0 meters. I can make that decision. I can make whatever decision I want about the initial position. I just have to make sure that it's consistent with the rest of it. So anyway, my initial position is 0 meters. The second piece of information that I always get is, what is my final position? And I've been told if the runway is 150 meters long, so that's the constraint that I have, my final position has to be 150 meters, and by that time my airplane better be traveling at least 27.8 meters per second. I don't know how long it's going to be or how fast it's going to be going, but it better be at least 27.8 meters per second. Okay, so my next piece of information that I gather is my initial velocity, and I'm not told what my initial velocity is, but I'm assuming that it's 0, because before it takes off it has to start at 0, right? And then I don't know what my final velocity will be. I would like it to be 27.8 meters per second, but I don't know what it's going to be, so it's a question mark. That's what I need to find, is what is that final velocity. But I do know that as it's accelerating, it's going to do this. It's going to increase its speed in a positive direction. And these arrows are important for me because they tell me what the direction of my acceleration is going to be as well. My acceleration has to be in the direction of increasing length of the velocity vectors. They don't have to be going the same direction that the acceleration is. They just have to be going in the direction of increasing length. So I have the smallest one here, the next one, and the next one, and the next one. So my acceleration has to be going in that direction. Otherwise, I wouldn't be increasing in speed like this in the positive direction. So my acceleration then, I've been told, is going to be 2.00 meters per second squared. Okay, so now that I've gathered all this wonderful information, I can write it down in a way that's useful to me. I can write it in a list. So I can say x0 equals 0 meters, x equals 150 meters, v0 equals 0 meters per second, and I don't know what v is. That's what I need, so I'm going to put that in my need list. Okay, and then my acceleration is going to equal 2.00 meters per second squared. I have not been given a time. So in saying I have not been given a time, I've already figured out what formula I have to use. And I'll show you why that is in just a second, but I haven't been given time. So now I'm going to say, what formula do I need to use to solve this? Okay? I don't know yet exactly how this is going to work out, but I don't need to know. I just need to know what this set of information is going to allow me to do in terms of formulas. And my first question that I ask, we're going to follow our logical questions, right? The first question I ask is, do I have time or do I need time? And the answer to that is no, I do not have time. I don't need time, but I don't have time either. So in order for me to solve any problem, it doesn't matter what it is, any problem in one-dimensional motion, in order for me to solve that problem, I have to use this formula, which doesn't require time. V squared equals V0 squared plus 2a times x minus x0. I have to use this formula. Okay, there's no choice. I do know that a couple of things have dropped out. And remember, we said that you should always start solving this by showing things that are going to end up being zero. I know that my initial velocity is zero, so I'm going to cross that out. And I know that my initial position was zero, so I'm going to cross that out. And that leaves me with v squared equals 2ax. Okay, this is a lot easier for me to see what's going on. I need this final velocity here. So in order to find that, I'm just going to isolate that and take the square root of it. And my final velocity is going to be the square root of 2a times x. So now that I've got my formula, I can take that over here and solve it. So 2 times a, my acceleration is 2.00 meters per second squared, and then x is 150 meters. Okay, now I want you to notice something here. This is why we always use units, so we can see how they actually cancel out. If I multiply the units in the acceleration, meters per second squared, times meters, I'm going to get meters squared per second squared. Well, that's a weird unit, except it's under the square root. So if I take the square root of that, I'm going to get meters per second, which is what I want. I want the velocity, right? So I know that my units work out, and that helps me to know that I'm on the right path. And if I do this, I look at my final velocity, and it's going to be 24.5 meters per second. Okay, now that's not enough, is it? It's not going to reach the takeoff speed that I need before it reaches the end of the runway. So the next question then is, if not, what is the minimum length the runway must have? What is the minimum length that the runway must have? Now, I'm not going to make you redraw all of this because of the next question, because we can use a lot of this as part of our information. The only thing that I'm going to change is that I know that my x is not going to be 150 meters anymore. It's going to be longer than that, right? So I'm going to cross that out. And I don't have that value, and that's what I need. I need the actual x value now. So that's what I'm going to try and find, right? I'm going to try and find that x value. Okay. And what do I need to do to accomplish that? I still don't have time. So whatever I do, it's going to have to involve v squared equals v0 squared plus 2a times x minus x0. Okay? And so, again, my initial velocity is 0, my initial position is 0, so I've got v squared equals 2ax. But now I'm not trying to find the final velocity. Now I'm trying to find the distance that I'm going to go if my final velocity, and I'm going to need to put that down here, my final velocity is now going to be 24.5 meters per second. So what we're saying is, okay, I can't reach that velocity after 150 meters. My final velocity is going to be, oh, wait a minute, it's not going to be that either, is it? My final velocity needs to be 27.8 meters per second. Okay, this is my final velocity at 150 meters. My final velocity at the point I take off needs to be 27.8 meters per second. Okay, so that's my new final velocity. But I want x, I don't want v, so now what I'm going to do is divide both sides of this by 2a. That's going to cancel out, and so now I have x equals v squared over 2a. So I've isolated x, and now I can just plug those values in and solve. X equals, my velocity squared is 27.8 meters per second, and that's going to be over 2 times 2.00 meters per second squared, and that's going to equal, let me see here, 193.2. Had to go find out what it was. It's going to equal 193.2 meters. Okay, so this is where we're at, and let me just show you about the units again. So I'm going to square meters per second. So if I square meters per second, I'm going to end up with meters squared per second squared, right? And then I'm going to divide by meters per second squared. The second squares are going to cancel out, and 1 meter is going to cancel out there, and that's going to leave me with meters, which is what I want, right? That's my distance. Okay, so this is how we're going to solve this first problem. We did not need to know a single thing about how to solve this problem. Even when it came to finding out what formulas we're going to use, all we did was ask the question, do I have time or do I need time? And the answer was no for both of these, and that automatically meant I had to use that last formula. Okay, so go on to the next problem.